Okay, so continuing our discussion with photosynthesis, and as I said, I was going to pull in this simulation that looks at both the macro part, which we just got through talking about, where the sunlight is striking the leaf. We see the energized photons, all wavelengths of light. Underneath the side of the leaf, of course, is the stomata, where the CO2 or the gas exchange occurs. And then the micro part, of course, is our chloroplast with the thylakoids, and of course the stroma. Remember, thylakoids is where the light-dependent reaction occurs, and the stroma is where the light-independent reaction occurs. Okay, so let's get into this. Let's look at the next stage of our photosynthesis. So I'm going to mash play here. Okay, so the photons of light energy strike the surface. The energy flow goes to the stroma, and of course glucose is the end result, which is excellent. Let's look at the next phase. Now we're focusing on the thylakoids, and I want to make note of something very peculiar. Photosystem 2 is usually written first, and then photosystem 1. But you can see the wavelengths of light striking each one of these. These are going to represent those chlorophyll molecules that we had talked about that are going to produce those high energy electrons. Let's see what happens. All right, photons of light energy strike the surface of the chlorophyll. Electrons are getting excited. The next phase. Aha, here we have water entering into photosystem 2 to be split. So let's make note of the product when water is split. Did you see that? Let's replay. Water enters, oxygen is given off, and the 2 hydrogens, and then of course 2 electrons are the end result. This is the key for the next phase. Those 2 electrons are going to be used to convert ADP into ATP. Let's see that one more time. 2 electrons from water convert ADP into ATP, and then of course you're sent to photosystem 1. Let's look at the next phase. The 2 electrons are then picked up by the NADP plus to become NADPH. Let's see that one more time. 2 electrons, NADP plus becomes NADPH. Remember, NADP plus is just an electron carrier. She's got a super sexy name, but let's just call her electron carrier. All right, so our next phase in the animation. So the ATP that is generated and the NADPH that's generated are then sent to the stroma for the light-independent reaction.